Okay, so let's now design. Let's take an example by which where we will see that how we can use this LL1 parsing table and the stack to check whether a particular string is the language or not. So to do this, obviously I will take not so complex example. I will take a very simple grammar. For example, the grammar is like this: S2 closing brace is opening brace. I'm sorry, opening brace is closing brace or lambda. That's all. So from this grammar, it is very clear to all of you that definitely this particular grammar is generating, you know, I mean, a string like a to the power n, b to the power n, right? Where a and b are complemented. I mean, all only opening braces, a number of opening braces, and then a number of closing braces, where opening brace and closing brace should be same. Now, to design, first of all, how the parser work, I mean, to understand how the parser work, first thing that you have to design the LL1 parsing table for this particular grammar. And in this particular grammar, I have only one symbol, I mean, non-terminal, and only one terminal. I mean, sorry, two terminals, closing brace and opening brace, and only one non-terminal, that is capital S. So, designing of the corresponding LL1 parsing table is very easy, I think. Right. So, what will be the table look like? Like I have a S here, and we have say closing brace here, say opening brace here. Then we have a closing brace here, and then we have a, obviously I have to have a dollar, right? So where I will put this S to this particular one, S to opening brace, S closing brace. Where I will put in the first of this LHS, right? That means I will put S to this one over here. And where I will put S to lambda, obviously in the follow of the left hand side, that is follow of S. And what is follow of S? You see, in this particular grammar, you can, I think, easily understand what should be the follow of S. First of all, S is start symbol, so follow of S has to be dollar. And other than dollar, you see S is followed by a closing brace in the production rule. That means follow of S is closing brace and dollar. That means S to dollar, S to lambda, you will write over here as well as over here. So this is basically your LL1 parsing table for this particular grammar. The grammar is very small, and definitely that's why the table is very easy to design. Now assume that we have to find uh, we have a string W looks something like this: opening brace, opening brace, closing brace, closing brace, right? And we all know that it has to be followed by a dollar, right? So this is your present in some tape. So this is your input tape present over here, like this. Now you see that we know one thing, that always there will be some look ahead or read pointer that points the first character of the string at the very beginning, and we have a stack we have seen. So question is that what is the algorithm? So we will try to understand the algorithm with this example. So I'm not writing the algorithm over here because that is not required. Just understand how the algorithm works. So that means we have a stack over here, right? We have a stack over here. We have a stack here which is filled up by some, which should be filled up by some characters, but initially the only thing that I have is dollar, right? Now you see, the first thing that the compiler will do, that it will check. It will check. Oh, by the way, not only dollar, it will have, after dollar it will have the, initially it will, the stack is filled up by the dollar and the start symbol is. Now what the compiler does? Compiler check the top of the stack with the read pointer. Okay. So just remember one thing, these are some important points that you have to remember, that you should write check top of the stack with the pointer symbol, with the pointer, with the pointer. Okay. This is a point you should remember. This is, I mean, a note number 1. Now see, this S on opening brace. In this particular table, what is said? It is said that S on opening brace, we have to use this particular production rule. S followed can be written as opening brace, this capital S, closing brace. So basically, I can say, we will use, if I say that this is rule number 1, this is cell number 1, this is cell number 2, I'm just writing it, the numbering it so that I can easily write it over here. So I'm writing it 1 so that you can map. And what will happen? You see, the content of the stack will change in something like this. Just let me write it, then I'm telling you. What we had in this stack? We had a dollar and there is a S, right? And what will happen, you know, the dollar will be obviously there. This S will be popped out from the stack, and instead of S, this RHS will come. I mean, LHS will be popped out and RHS will be pushed in the stack. But RHS is pushed in the reverse direction, right? That means this opening S closing, so it will done something like closing, then S, then opening S. Okay. So here is the next point that you have to remember. Let me write the next point. The point number 2 is when we put RHS of any production rule, we should push the RHS in reverse direction. This is point number 2. Okay. Now see, after pushing it, it will check what is the top of the stack. the top of the stack, then I'll have a match on the top of the stack with this pointer. Since there is a top of the, there is a match, so I can say then there is a match. So what we will do, we will pop and increment. What does it mean? Then that means we have to understand, we have to go through the third point. Point number 3. What is point number 3? Point number 3 is saying that if there is a match, with top of the stack and pointer, then only pointer is incremented. Then then only pointer is incremented and the character is popped out. This is point number 3. So if a problem is given to you, you have to follow these points to get your final result. So ultimately what will happen? There will be the character, I'm sorry. The there will be a dollar closing brace S only up to this. So that means there will be dollar closing brace and S, and your pointer will get incremented over here. Now same thing, S on closing opening brace. What is this? Again number 1. So that means again number 1. And what will happen as a result? What will be the change on the stack? So let's write it one by one. And content of the stack will be obviously dollar, then closing brace, and this S will be popped out, right? S will be popped out, and instead of S, the right RHS will come in reverse direction. That means again it will come as this one, S, and closing brace, opening brace, and then I will see that again this top of the stack has a match with this pointer head. So there is again a match. So naturally again pop and increment. So as a result, what will happen? I will have a scenario something like this. Like this. And you see the content of the stack will be something like dollar, followed by closing brace, followed by another closing brace, and followed by S. Now see, after doing this, obviously pointer will be incremented, so pointer has been incremented once. So now see, top of the stack is capital S pointing to closing brace. So S on closing brace, according to the table, it is S2 lambda. S2 lambda means what? It's just popping out from the stack. That means number 2 will now work. Number 2 will work means what? Number 2 will work means the top of the content of the stack will look something like dollar closing brace opening brace. That's all, right? It will be dollar closing brace, sorry, closing brace. And after doing this, you see we have a match again, right? Since we have a match, that means again pop and increment. Increment means increment of pointer. So that means what will happen as a result? The content of stack will be, just a minute, the content of stack will be something like dollar, and above that we have only one opening brace, closing brace. And you see here, this is a closing brace, and here again, oh, one more thing, increment the pointer. So pointer will be incremented. And you see now top of the stack doesn't contain any symbol, so you cannot use exploit this particular uh, particular LR parsing table over here. But here you can match again with the top of the stack and this particular pointer character which is pointed by the loop arrow. So again we can say that we have a match. That means pop and increment. So that means now the content of the stack will be something like what? Only the dollar will left, and you see after doing this, obviously there will be an increment over here. Now see, in this situation, top of the character, now the top of the character, top of the stack actually, equal to what? End of the string. Right? That we have seen, dollar and dollar, which says that it is accepted. Now if you find there is one more symbol, for example, by any chance, if I take another say for example string W, which is basically something like opening brace, then 3 closing braces, so naturally you can say that this is correct, this is not correct, and there will be a dollar at the end, right? Now see, in this situation, this will be in the tape, and each and every characters on each and every cell, and you see after in this situation where you are in dollar, and this pointer is also pointing to dollar. The reason only is that there is number of characters are same. So definitely, if the scenario is something like this, when stack contain dollar, your read pointer will point to this closing brace. And dollar on closing brace is definitely, it is not possible. If you are correct, then whenever everything will be vanished from the stack, I mean only dollar will left, then definitely the pointer will point to the dollar. If it is not, then definitely you have some error in this particular string. And this is a way by which the LL1 parser can find whether the string is correct or not. In other words, whether the program that you have written is syntactically correct or not. So this is a example we have discussed by which you can understand how the LL1 parser works.